All right, this is lesson 3.1 on inequalities and their graphs. This is the first lesson in chapter 3, so it should be fairly basic and fairly simple. So I might go just a little bit quick. At any point, if you get confused, you can go ahead and back it up and watch it again, and make sure you take 2-column notes. So the first thing you should do is set up your notes. Make a 2-column note. This is lesson 3.1 on inequalities. The essential question comes from the learning target, which is write, graph, and identify solutions of the inequalities. So a good way to write an essential question is just to add the how do I write, graph, and identify solutions of inequalities. So you can hit the pause button while you get that set up, and then hit play when you're ready to go. Okay, a quick review on inequalities. The less than and greater than symbols. This is something that you probably should have been taught in elementary school when your teacher showed you a picture of an alligator and said the alligator always eats the bigger number. These are inequality symbols. This first one is the less than symbol, like 2 is less than 10. The second one is the greater than symbol, like 5 is greater than 1. And if I add the little bar at the bottom of it, it now becomes a less than or equal to, or a greater than or equal to. So if I write 4 is less than or equal to 4, is that a statement true? It is true because 4 is either less than or equal to, and in this case it's equal to. All right, what you'll see in this lesson in your assignment are several types of problems. The first one, we'll take word phrases, which you'll have to translate into inequalities. So this first problem says all real numbers x. That just means all real numbers x, or the letter x, less than or equal to. That means you're going to write the less than or equal to -7. And it's that simple. Now, there are a few that are a little more complicated because they add in a few more words that make it a little bit confusing, like this one. This says 6 less than a number k is greater than 13. That does not mean 6 less than k greater than 13. That doesn't make any sense. So the word less than in this problem really means subtract. So this problem means 6 less than the number k. And you write 6 less than the number k like this. K, 6 less than that. The word is the key to finding where the inequality symbol is going to go. This is says is greater than 13. So the first type of problem you'll see on the assignment, you'll take words like this and you'll write them as an inequality. The second type of problem will look like this. You'll be given an inequality and you'll be asked if a given number is a solution to that. Now you remember in equations, x plus 1 equals 2. An equation has one solution. There's one number that makes this equation true, and that number is 1, because 1 plus 1 is 2. In an inequality, there's a whole bunch of numbers that make it true. If I said x is greater than 2, how many numbers make this inequality true? That's an infinite number of numbers. 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, and so on. So in this problem, you're trying to figure out, is this one of the problems or one of the numbers that makes this equation true? And you figure that out by replacing the letter x with the number 3. So you put -3 in place of x, and you check it. 2 times -3 is -6. -6 plus 1 is -5. Is -5 greater than -3? And the answer is no. So on problems like these, you're going to show a little work and then answer either yes it is or no it isn't. Look at the next one. Is -1 a solution to this inequality? Put -1 in place of x. 2 times -1 plus 1 is greater than -3. 2 times -1 is -2. -2 plus 1 is -1. Is -1 greater than -3? The answer is yes. So for this type of problem, when you're asked if it is a solution, your job is to just check and answer yes or no. In the third type of problem, you're going to take an inequality and graph it on a number line. So here's the expectation for graphing inequalities on a number line. If you're given an inequality like x is greater than 0, the number is the number that you place in the middle of the number line, and add a couple numbers to the right, 1, 2, add a couple numbers to the left, -1, -2. This problem says x is greater than 0, strictly greater than. So all the numbers that are greater than 0 are on the right-hand side of 0. So you're just going to draw an arrow that points to the right and goes on forever. In this problem, can x be equal to 0? The answer is no, so you show that with an open circle. So open circles on graphs are only for less than or greater than. In the next problem, x is less than -2. The number involved in this problem is -2. So I'm going to start in the middle of the graph with -2. I'm going to put numbers to the right, -1 and 0, numbers to the left, -3 and -4. All the numbers that are less than -2 are the numbers that go to the left, so I draw an arrow to the left. It's only less than, it's not equal to, so I put an open circle. If the less than or equal to symbol is used, you start the graph the same way. Right smack in the middle of the number line, you put the number in the inequality, that's 4. Put a couple numbers to the right, 5 and 6. Put a couple numbers to the left, 3 and 2. All the numbers less than 4 are the numbers to the left. Because of the or equal to symbol, that means x could be equal to 4, so you show that on a graph by filling in the circle. So these are called closed circles, and all the closed circles are reserved for less than or equal to or greater than or equal to. So try the next one. X is greater than or equal to -5. Pause it, write your answer, and then check. Okay, you start with -5 right in the middle of the number line. Put a couple numbers to the right. -4, -3, a couple numbers to the left. -6, -7. Remember, negative numbers as you go to the left, they increase in number but decrease in size. So -5, -6, -7, so on. All the numbers greater than -5 are always to the right. It's or equal to, so I fill it in and have a closed circle. All right, the fourth type of problem is the opposite of the third type of problem. Instead of giving you an inequality and asking you to graph it, I'm going to give you a graph and ask you to write an inequality. So in this problem, the number that the line or the arrow begins at is -2. So you write -2. This graph represents all the numbers that are greater than -2. So you write x is greater than -2. The circle is open, so you leave it greater than. And that's your answer. If this problem had the circle filled in, then you would add the or equal to. And that's pretty much it. And finally, the last type of problem has to do with words or a story type problem. This picture depicts an advertisement for trail rides, and the trail rides are starting at $19.99, which means the cost for a trail ride, T, is going to be $19.99. But the word starting at implies that it could be more than $19.99, so the inequality that this picture represents is greater than or equal to $19.99. Here's another one. It's a speed limit sign. The speed limit is 8 miles per hour. That means that you can travel at a speed S. It has to be 8 miles an hour. Legally, you're not supposed to go over 8 miles an hour, so the speed, or S, has to be less than or equal to. And that's pretty much it. That's lesson 3.1. Check your OneNote notebook for the assignment. And that's it.